The acceleration due to gravity on the moon is about 1/6 what it is on Earth. If an object is thrown vertically upward on the moon, how many times higher will it go than it would on Earth, assuming the same initial velocity?
What is the acceleration due to gravity on Earth?
Negative 9.8 meters per second.
Meters per second squared. Yeah, perfect.
Yeah. And I think to calculate for the moon, you would divide that by 6, or 1/6.
Perfect. So I'm going to put G for Earth, and let me know what you get for the gravity acceleration on the moon.
I got 1.63.
Nice. Yeah, I'll put it completely there. Meters per second squared. Awesome. I'm just going to come up with an arbitrary number here, because sometimes it's easier to do it with numbers. But they said in the problem that we're going to assume the same initial velocity. I'm going to assign an initial velocity of 10 meters per second. Can you calculate how high it's going to go on Earth? And I'll give you our kinematic equations. V final equals V initial plus AT, delta X or delta Y, some people use delta Y for vertical distance, equals V naught T plus 1/2 AT squared, V final squared equals V initial squared plus 2A delta X.
I think we should use number 3.
Nice. What would V final be?
0?
Perfect, because it's at the top of its trajectory essentially, or in this case, just the top, because it's going straight up. Awesome. Let's go ahead and I'll have you calculate delta X, or the change in height on Earth. So that's going to be using this acceleration.
Negative 196 as delta X.
Not quite what I got. It seems like you multiplied the 100 and the 19.6. But that's not the process we should be using. Do you see my work here?
Oh, then I got 0.51.
Close, but also not quite. You're off by a factor of 10.
Oh, because you squared the 10.
Right, exactly. So we do 10 squared and 2 times negative 9.8. Then I move the 19.6 delta X to the other side by addition. Divide both sides by 19.6. And your final answer is very close. I get 5.1 meters. This is how high it'll go on Earth. I'm going to put a circle around it because it's not my final answer. I like to box my final answers. Now, can you calculate the same thing but for the moon? How high will it go on the moon? And for this one, we're going to use the gravity on the moon, which is negative 1.63. Just showing what I deal with here the whole time we're working. I don't know if you can see this, Matt. This dog doesn't stop. You're busy, that's good.
I got 30.67 meters.
Awesome, that's exactly what I got. And I rounded mine to 30.7.
Oh, good. I remembered
Nice.
to square the 10 this time.
Perfect. Yeah, getting better at it. I know it's been a while since we practiced these. Now, they weren't actually asking for this. They were asking for how many times higher will it go on the moon than it will on Earth. So what do we have to do with these results?
Could we divide 30.67 by 5.1?
Yes.
Oh, this is great that we backed it up, but didn't I solve the problem by saying, oh, it must be 6 times higher?
Yeah, you
Wasn't
did.
that the answer?
Yeah, that is the answer.
But this is how we were certain of it, by just plugging in an easy number like 10 and then seeing the differences between the two after we determined that it was 6 times or so the force of gravity.
Exactly. Perfect.
Okay.
And this makes perfect sense because the gravity gets divided by 6, and there's nothing getting squared as far as the acceleration or the distance goes. You know, they're just linear. So it makes sense that it would go 6 times higher.
Brilliant.
Yeah, this was good. Very clean problem right there.